welcome back. In this brief lecture, we'll introduce some aspects of gamma decay. Gamma transition refer to many things, but the essential feature of gamma transition is that there is no change in the atomic weight or the atomic number of the nucleus. All such transitions are referred to as gamma transitions. All these transitions involve the de-excitation of the nucleus, and correspondingly, there is an energy release. The most common gamma transition is that of the release of gamma photons. Perhaps this is what you've been familiar from your high school, but there are other forms of transitions which fall under gamma transitions. So the gamma photons that are released can be detected. There are lots of important class of detectors which help you measure the energy of the gamma photons. Perhaps the most common detectors are based on silicon and germanium-based solid-state detectors. The energy can be well quantified. There are other forms of gamma transition besides the release of gamma photon. An important class of gamma transition is called internal conversion. So there is an electromagnetic interaction between the de-exciting nucleus and the outer electrons. Okay, so these electrons are not coming from within the nucleus. So these are the electrons that are present outside the nucleus, and the energy released during de-excitation causes the emission of these electrons. So depending upon the energy involved, the release of the electrons can be from different shells present outside the nucleus. Then, if the energy is greater than this number, this is the rest mass of electrons. This is the energy equivalent of twice the mass of electrons. If the energy that has to be released is more than this, a pair of positron and electron are created, and this pair is being released. So this is the most common. The next to that, this is common. This is rather rare. So the lifetime of the excited states can vary a lot. So there can be sometimes very short half-life, but some things can be very stable. This can be the half-life. So it depends on certain details. We'll look at these things in the next few lectures. If many times there is a separation between the initial state and the final state, they differ because of the differences in nuclear spin, and the energy is also different between the initial state and the final states. The de-excitation from a higher energy state to a lower state are often referred to as isomeric transitions. They're given the symbol IT. So all these transitions had important implications that suggested the organization of nuclear structure within nuclear shells. Okay, so before nuclear physics, nuclear science was born, idea of shell model was useful in the context of arranging electrons in different shells. But these kinds of isomeric transitions and many of these features pointed to the possibility of a nuclear shell model. So much of the proof that experimental proof that is provided for nuclear shell model comes from these kinds of gamma transitions. In the next lecture, we will look at multipole radiation and selection groups. Thank you.